Hi, this is Mrs. Thompson. Today's lesson that you're looking on, 2.2, solving two-step equations. Our Common Core Standard, AREI3, to solve linear equations and inequalities with one variable, including equations with coefficients represented by a letter. I know most of you last year solved some two-step equations. When you were in pre-algebra, you may have seen this equation, 2x plus 3 equals 15. And to undo the operations, you need to do it in reverse order of your order of operations. So the order of operations says multiply first, then add. In order to solve equations, you're going to do it in reverse order. First, you will always undo your addition and subtraction using your inverse operation, then undo the multiplication and division. I'm going to ask that you show your work as you're doing these because the problems start getting kind of complicated real soon. So if we are looking at this and it says write the inverse operation you would do to undo the operation, we're actually going to go through and solve all three of these so you can see solving them. And our first step in doing this is to first, if I have 3 times r or 3r, I need to do the inverse operation, which is subtracting 16. Now some of you might prefer to draw this line going down. That wasn't very straight, but you kind of get the idea. To kind of show where your equal sign is, we're going to be talking more about our properties. The addition property or subtraction property of equality lets us subtract 16 from both sides. So if we are doing our subtraction, if you are doing your subtraction, we would now have 15. On this side, this would negative 16 and positive 16 adds to 0, or they cancel, and we're left with 3r is equal to 15. If 3 times r is equal to 15, the opposite of multiplying by 3 is to divide, and you're going to show that division on both sides of your equation. I understand that most of you could do this in your head and tell me your solution, r equals 5. Remember, anytime you solve an equation, you can always check your solution. How would you check your solution? Remember to check. And anytime you're solving equations, you should be doing this. You are taking 3 times and replacing in your original equation the r with 5. So 3 times 5 plus 16, and we're trying to check, does that really equal 31? And in this case, 15 plus 16 does equal 31, and it checks. If we are looking at our next equation, 1/2 times d minus 7, the inverse of minusing 7 is to add 7. Some of you that solve these problems horizontally, I'm going to try to get you to do it vertically. We now have 17 is equal to negative 7 and positive 7, 0. That is our inverse operation, inverse additive property. 1/2 d, 1/2 times d is equal to 17. Well, if I want to have a 1 in front of d, our coefficient, what am I going to multiply 1/2 times? And it's actually its reciprocal. The reciprocal of 1/2 is 2. Sometimes it helps to see it as 2 over 1. And on this side, 17 times 2, d is equal to 34. Again, you should be doing the check. What is the check for this one? You go back to the original equation. In the original equation, you had 1/2, but now instead of d, we take 34 minus 7. Half of 34 is 17 minus 7. Does it equal 10? Yes. So it is a check in this point. Number 10, does it matter that the 5y plus 2 comes behind the equal sign? It does not. If we are looking at that equation, first step, opposite of adding 2 is to subtract 2. Someone said, should I put plus a negative 2? You could, but remember that is the same as subtraction. 10 is equal to negative 5y. If we are solving that, the opposite of multiplying by negative 5 is to now inverse operation, divide by negative 5. So negative 2 is equal to y. Does it matter if you put the y first and put y equals negative 2? Same solution. Again, if we look at our check, anytime you're checking in an equation, and you always will want to do this on a quiz or test, go back to the original equation. And the question is it true that 12 equals negative 5 times negative 2 plus 2, or 10 plus 2? And it does check, so that is a solution. Now, as you're looking at this equation, some of you may have solved some problems like this last year. Some of you may not have. As we look at our original equation, we want to be thinking first of isolating, if you notice this, it talks about isolating x. So when we look at this equation, we're going to think of this as putting a parenthesis around here. The main reason, if we think of a parenthesis around our numerator, we're getting the x minus 2 divided by 4. If you think of this as just one quantity, the opposite of dividing by 4 is to multiply by 4. We're going to multiply by 4 on both sides of our equation. It's not that hard of a problem now. We now have 24 is equal to x minus 2. Again, the opposite of subtracting 2 is to now add 2 to both sides of the equation. When we add 2 to both sides of our equation, 26 is equal to x. Does it check? Always going back to your original. Never your first or second equation, always your original. So the question is 6 equal to 26? We replace our x with 26 minus 2. Again, if you need to watch this video a couple of times to refresh your memory with solving equations, you should do so. Again, as we look at solving this, does it check? 26 minus 2 is 24, and 24 divided by 4 does equal 6, and it checks. Here's another equation with division, very similar. You notice that the first step, they kind of do this problem horizontally. They add 5 to both sides. Once we add 5 to both sides, we are left with x divided by 3. The opposite of dividing by 3 is to multiply. What they are looking for is you writing down your properties. Now, if you look in your textbook, you're going to see many of these different properties. So by adding 5 to both sides, that's called our addition property of equality. The addition property of equality lets us add the same number to both sides. Once we've done that, we then simplify by adding our like terms. What were our like terms? Our like terms were the 5 and negative 5, 4 and 5 to give us the 9. Next, we are multiplying on both sides of our equation by 3. So here would be the multiplication property of equality. Multiplication property of equality. And you solve to get 27. And again, you'd want to do your check. Here's just kind of a quick understanding. If you look at this problem, what properties of equality would you use to solve? Circle the operation that's going to undo when you solve this. So circle the operation, you'll undo. The first one we have to undo is addition. The second one we have to undo is division. So when we look at our different properties, the key thing that we're going to work with is solving the problems and looking at your properties. If you do have any questions tomorrow in class, we're going to be doing quite a few solving problems. Have a good day.